Hello, everyone. The session will be starting right now. Thank you for those who came on time. We're going to start with a very short video. All right, everyone. Thank you for attending this session. To remind you, welcome to the Tech Week Bootcamp, which is organized by all the developer student clubs in Saudi Arabia, thanks to all the universities you see in front of you, with all their core team members and all the people that helped make these sessions happen. Now, to remind you all, the Tech Week Bootcamp has all of these workshops. It also includes many different activities through the clubs themselves. And this session specifically will be given in English in order to include other target members and to include everyone and not leave everyone out. So this session will be exclusively given in English. And thank you for coming. Now, this is our 6th session. Without further ado, let's begin. The brain of a computer, given by yours truly, myself. Allow me to introduce myself before I start. My name is Ragad Zara. I'm a computer science student at Affat University with a concentration of artificial intelligence. Now, what you should be expecting from this session is to get to know about computer architecture, to apply some assembly language through Little Mind Computer, to know the difference between high-level and low-level languages, and the different uses of programming languages, as well as cover the part of competitive programming, and finally, why you need GitHub and Stack Overflow. All right, let's get to the big question. What is the brain of a computer? It's such a broad question, but you always thought of it as a child. What did you think as a child? How did you think your computer worked? For me personally, I really did not know. I just thought someone kept putting papers or something like that. But as I grew older, I heard the term CPU. And that's what all of us know. The brain of a computer is a CPU. In fact, the first time I knew that CPU was the brain of a computer was from video games. I remember being on a GameCube, and if you played alone and the game required more than one player, they were called CPU1, CPU2, and that's exactly what it is. The characters come to life by being controlled by a CPU. Now let's think, how did the CPU came to be? Why is it the factor that makes our computers run? Now, I won't be going through all this computer history. I'm sure I don't want to bore you with it, and I'm sure you've heard of it before, but let me tell you about the most important factors that led to having the computers we have nowadays. Starting with the Turing machine, the most important thing about it is that it was the most popular non-mechanical computer. Of course, it was a secret at that time since it was used to decrypt code by the Nazis and things like that. It was used mostly for the World War. And then comes the ENIAC, which most of you know about it because it's up till today recorded to be the first non-mechanical computer. And that was the biggest invention of history because guess what? What was great about it is that it calculated over 5,000 math calculations per minute, which is not considered that surprising now. But at the time, this half a room computer was able to do that. Imagine if that was the case nowadays, half of your room would be a computer, and then it's very tiring. Now, the other important thing about the ENIAC is that after this type of computer, all they tried to do was try to see how to make the computer work faster rather than change how the computer really looks from the outside. So then came transistors to make it really fast and process information better. And then the people who made transistors went, why couldn't we put so many transistors together in order to create a faster computer? And that's why integrated circuits came. And then guess what? After integrated circuits came, they said, why not put it all on a silicon chip and put so many integrated circuits? And then Intel created the microprocessors. And then you can only guess what happens nowadays. They take several microprocessors to create a CPU. All right, so the present is what you see, having different CPUs with different capacities of different computers. So what do you think the future is going to hold? Of course, putting several CPUs together, right? And that's exactly what's going to happen with quantum computing. If you're interested, read more about it. It's the next target where people are heading in order to create a revolutionary step in the history of computing. Now, let me tell you about one thing that was common between all those people that tried to have different methods in computing. All of them had one target. It was a very similar target, which was to store data into the computer through different methods. All of those people, they wanted to find ways to put large amounts of data, process it, evolve it in a very fast manner. And that's why we have computer architecture, and it's exactly what it says. This is computer architecture, which is to find different methods to implement data into a computer. Now, let's talk about the most popular computer architecture, which is the von Neumann architecture. To briefly explain the components of it, it has, of course, the CPU, which we all know. It has a control unit, which is the master. It controls everything that happens. There's also the ALU, the arithmetic logic unit. This is where all the mathematics happen if needed. Also, the memory is there, which is considered to be the RAM, the read-only memory. This is where everything happens. This is the main of the CPU, and everything else is considered to be input or output devices. This is going to be so clear when we try to implement it through our practical session. Now, of course, to contact that CPU, to contact this little complicated brain, we used ones and zeros because that's the machine language and it can't understand anything else. But later on, the assembly language came, and then as the name says it, it assembles the ones and twos to create commands that are easier to humans. We're going to try to implement the codes, but allow me to explain them first. As you can see, I'm going to start from right to left. The description says load the value 2 into the accumulator, basically into the CPU itself. The assembly code says load 2, simple as that. The machine code has the numbers of the command load. Load is 001, as you can see. It takes the command and then the value. Our value is 2 over here, so as you can see, it's 0, 1, and then anyways, you can see the difference. Let's go to the next one. It says store the value of the accumulator into the memory location 13. The assembly code is store, and as you can see the number, the machine code turns it into ones and zeros. And that's exactly how your computer works. You just don't see this side of your computer. However, we're going to see this side today by implementing it through a machine called the Little Man computer. I'll be sending you my team will be sending you the link soon, as well as with the instruction set. To briefly compare it with the von Neumann architecture, as you can see, this part is our CPU, this part. And then we have the memory, which is our RAM, where everything gets saved, and then the input-output devices, and this is where we are going to write programs. Now, without further ado, allow me to go into the practical part. Make sure also to open the website and follow along with me. Okay. All right, allow me to just delete those. Okay. Okay. Kindly enter to the website. The team is going to send it now along with the PDF of the instruction set. We're going to try to implement methods. All right, once you're all set, let me know in the chat. Let me know that you entered the website and have the instruction set ready. Okay, allow me to open mine so we can start implementing it together. All right, is it all clear to you? Do you see the instruction set and the codes. All right. Okay, we'll be implementing a very, very simple task. Something very, very simple, which does not, which shows you how computers can work, as well as show you what happens behind the architecture of your computer. All right, let's try something very simple, adding numbers together. All right, so as you can see, the instruction manual on my right has several instructions, along with the mnemonic code, which you can write for the assembly language. And then, of course, it shows you the machine code. To make it very clear, allow me to show you, demonstrate by writing the first set of codes. Now, let's say we wanted to add two numbers. All right. First of all, we can ask input from the user. So what does input say? You can go back to the instructions and you can see that the mnemonic code is INP, and that's exactly what you do, right? INP, you wrote your first assembly instruction. Now, after that input is taken, you want to store it. Think about it. This is a CPU. It's, at the end of the day, it's a machine. You have to literally tell it what to do exactly. After inputting this value, I want you to store it. It's not like you do in high-level languages. You just give it, you just create a variable and then give it a value. This is not how it actually happens. This is what actually happens behind all what you do in the compiler. All right, now after we have our input, we want to save it. So store, go back to the instructions. You're going to see that store is STA, and then it requires an address. Now, okay, we want to store it. I suggest, let's say in the memory, the location 99, then you write, I want to store it in 99. Those are very simple codes. We've taken in a number and saved it into this address. Now, we also want to take another number, right? So we can take another input and also store it in the location next to it, which is 98. Now, all the program that we have written does is take in an input, store it, take another input, and store it. Now, let's say we want to add these two numbers. You can go back to the instructions and see that we have an instruction called add, which is very simple, just add. All right, so since our last digit in the CPU was the number we stored in 98, we want to add it to the other number, which is 99. So you say you want to add that number to what we have in 99. All right, now let's try to submit and see how things happen. Now you can work on this on your own and you can see how things exactly move behind your computer. Of course, it's moving very slow right now. The CPU is going to fetch this instruction from the first location of the memory. It's going to process it. It's going to check the number of the instruction, which is 9, and then the address of it. See, it already asked me for an input, which means the first instruction has been done. Let's say I want to put 5 and then click enter. The input is going to go back to the CPU, and the CPU is going to roll to the other instruction. This is literally how it happens behind your computer. It is this slow, it is this not complicated, it is this detailed. All right, and since I asked for the number to be stored in the location 99, that's where it went. It went to 99, saved it in the CPU, it stored it there, and it's gonna go on. Of course, we can make it faster for the sake of time. I want to put another number. I'm gonna put a 2. All right, it's gonna go back to the CPU, get processed, and get saved into the location I have set. All right, let's make it faster. All right. All right, later on, we wanted to add those two numbers. Okay, we wanted to add the number we had last, which is 2, the one we stored in the location 98, with the first number, which is 99. That's why we add 99. Notice that the accumulator shows the added number, and that's exactly what we wanted. But we did not ask the machine to output this number. So you're going to have to add an output instruction. Go back to the instruction manual. You're going to find that there is an output over there. Make sure to add it, and then it's going to be outputted in the output section. So this is a very simple set of instructions that we have done to demonstrate how things go through your computer. Of course, we can do so many other complicated things that you usually see or do through high-level language instructions, all right? So let's take a more advanced code, all right? Bear with me in this practice. It's really going to help you know what happens behind what you program. This is the step that happens after you write your program, and then this step converts it into machine language. All right, let's try another example. Let's say we want to add, we want to give the CPU two numbers, and we want it to notice or tell us the difference, which number is greater. How you can do that is by the following. Now, I want you to think with me, work along with me. Okay, let's input numbers from the user first. Okay, let's take a number. Store it in a location that's away from the set of instructions. That's why I recommend saving it into the addresses starting 99. Let's store it in the location 99. All right, that's our first number. And then we want to take another number and store it again in 98. Okay, we've done the first two steps, take in two numbers. Now we want to compare those two numbers. Normally, in your normal compiler, you just put if this number is greater than this number, then output the greater number. And if not this number, output this. It's very, very simple, and you don't have to think much of it. However, if you think like your computer, you're going to have to think, how can I tell which number is different? Give it some thought. You have two numbers. How can you tell which one is different? So, as I mentioned, order matters so much in your computer. So the last number we added is the second number. All right? So if we subtract the first number, it's going to tell us several things. If those two numbers, subtraction, gave me a positive number, then the first number is greater. If they were equal, if it gave me a 0, it means the two numbers were equal. If it gave me a negative, then the first number is less. So what we're going to do is subtract the number we last stored, which was the 98. We're going to subtract from the first number we added, 99. All right? After we subtracted those two numbers, there's a function in the instruction set called branch. Branch if 0 or positive, which is exactly what we want. If we subtracted those two numbers, if we got a 0 or a positive, it means the first number is greater or equal. If it gave me a negative number, it means the first number is less. So we're going to use this function. It's called, the mnemonic code, as you can see, is a BRP. BRP, all right? Okay, it literally means to branch if. So where do you want it to branch to? We're going to find that out later. So we said if it branched, if the two numbers gave me a positive or a 0, it means that we need to load to the accumulator, LDA. You can check it in the instruction set. We want to load the first number we had and output that number. Simple as that, right? Because we wanted the program to tell us which number was greater. However, if that number was a negative, we want to load the second number and show that it was the correct number. Okay, so I'll be writing. Okay. Okay, mix those up a bit, all right? Okay. All right, so allow me to go back to the branch. we didn't tell the codes where to branch, to which set of instruction. Now see, if I submit, you can tell that each instruction has a number as well, all right? So if, let's follow from here. Okay, we had first input and then another input. Then we wanted to subtract. If that was positive, we wanted to branch somewhere. If it was positive, we want to load the second number and then output. If it was not, so we basically want the program to jump all the way to this step, correct? And this step, as you can see, is 8. Okay, it's 8. So you branch this number to the instruction you wanted to go through. Okay, so I'm going to be writing 8. Now, I want you to notice if it was not positive or 0, it's going to continue to the next set of instruction, which is to load the 99th code and then output. But then there are other instructions after, and I don't want the code to continue. So that's why there's an instruction called halt, which is to stop the whole process. By that, our code is complete. Let's check it out if it's going to give me correct values. All right, so the first number we want, let's say 5 again. All right, the second input was 2. Notice that the first number was greater. So if I submit, it's going to output a 5, which means it gave me a correct, this code is correct. Now let's try the opposite. Let's put the smaller number first and then the second to really check if the code worked. All right, I'm gonna reset. Of course, you can control the speed as much as you want. Let's put the 2 first and then the 5. All right, it's still okay. Okay, let me check the codes. I think the halt didn't. Okay, since we added the halt, yeah, see, so after we added the halt, the load program that we wanted became a 9 instead of an 8. So let's change the branch to a 9. Okay, by that, the code is going to work and it's going to output the greater number, even if we put the smaller number first. Now, as complicated as all those details might seem, this is how it happens. Okay, the code worked, and that's exactly how your computer works behind the scenes. Now, as for a challenge, I want you guys to try this program and give me a program that outputs 1 if the number I entered was even, and if number was odd, it outputs a 0. All right, let me just go back to the presentation. All right, so here's the challenge. As I mentioned, you can find the question at @DSC_. Make sure to tag Saudia and myself to check out your answers and see what you guys have. And also make sure to put the hashtag developer students clubs. Again, the prompt is, on your little man computer, make sure to write a program that outputs 1 if the input was even, and 0 if the input was odd. Make sure to take on that challenge and see if you can think exactly like your computer. Don't forget to find the question at @DSC_. And later on, to share your answer, make sure to tag @DSC Saudia and myself to check your answers and see what you guys come up with, as well as tag hashtag developer student clubs. Now, let's get to another part. So, as you can see, that this language I've been using, it's very, very low level. We can barely understand. It just says store, load, input, output, very, very simple. We cannot use that to write any program, right? We cannot literally use this language to, for example, make a website, right? That is why there are high-level languages and low-level languages. Can any of you provide me with examples of low-level languages and high-level languages? You can jot them down in the chat. I'll be checking. To give you an example, the things we had with the thing we wrote right now, the assembly language, the machine codes, all those are considered low-level language. But for the high-level languages are the ones you hear about all the time. Python, Java, C++, all those other languages you hear about, all those are considered to be high-level languages. Of course, there are several differences. The main things about them, about the high level and low level, the high level is considered to have a poor performance or a slower performance since it does not directly deal with the CPU. It's still going to convert into a low-level language and later into your computer. All right? So this difference between them is what makes the whole set of computers, the levels of a computer. As you can see from this diagram, directly after the hardware comes the machine language, which is the one we spoke about, the ones and zeros. Then later translates into the assembly language, which we just tried. And later on, it turns into the high-level language, which most people use throughout their work, through real life, pretty much. And later on to different types of languages and to the visual language. Now, there's a saying by Steve Yedge that says, if you don't know how compilers work, you don't know how computers work. I hope you understand what this quote is trying to say. Now that you know what happens behind your compiler, you know how computers work. You know that contacting the CPU requires way more steps than you think. It requires, of course, the machine language and the assembly and later on the language that everyone is used to. Once you know how the architecture of the computer works, then you definitely know what happens behind your compiler, behind all those codes that you can write on your compiler. Now, let's get to the high-level languages and talk about the top languages. Everyone gets really excited getting to know the most popular language or the language that is used the most or the ones that are going to get you a job. As true as all that can seem, there is some type of confusion. Many people think that there are certain languages that everyone should know, or there's a certain order that you should go through to learn programming. But in fact, all those myths can be debunked by the following thing I'm going to mention. Programming languages really depend on the major you want to concentrate on. Let's say you want to focus on security. None of those top languages might help except C#. Otherwise, you can use the shell language or things that are similar. Let's say you wanted to use to do app development, all right, specifically Android app development. Then the top languages might not help except Java or Kotlin. Kotlin is not in this list, but it is important for the Android development. So let's talk about web development. The main part of web development is HTML and CSS. Do you see it anywhere on the list? No. However, the top languages are just languages that you can use in several places. Let's say Python can be used in AI. It can be used as well in web development. That's why they're called the top languages. But as for a personal use, what you need to learn or how you want to focus is actually know the core thing you want to focus on, the core possession, the core skills you want to focus on. Let's say I was more interested in machine language. It's better for me to learn Python than waste my time on different languages. So it's better to focus on the area you really want to know, to get to more involved in and work in, rather than just learning random languages or trying to see what's the best order of languages. Check what you want and then check what are the most important languages that come along with the major you want. All right. Now, There are many different uses for programming, as the ones I mentioned in security, in web, in development, many different uh, technical uses. But there is one very fun use of it, which is the competitive programming. All right. Competitive programming is meant to encourage people to learn languages and get deeply integrated into those languages. So I'm not sure if you've heard of champions in programming, but there are actual people that are crowned every year to be the top programmers of that year. How you can get to that level, or how you can aim to reach to that, you can actually practice in so many different websites. The top 3 websites are Top Coder, HackerRank, and ICPC Foundation. Those are the top websites that you can actually find the questions that you will mostly face during the programming competitions and so on. And how you can get involved into those programming competitions. There are several competitions that you can go for, but the top 3 as well that I wanted to highlight is Code Jam, which is partly done by Google, mostly to involve people into programming. And then there is Hashcode, one of the top programming competitions. You know that the top competitors go on face to face with the Google employees, and some of them actually go on and get a job at Google itself or anywhere else. But seriously, those competitions can open spectrums and chances that can be endless for you. And for local competitions that you can start with, there's the Gulf Programming Competition. It happened in 2018 in Dubai, and unfortunately last year it was going to happen in Oman, but unfortunately with the pandemic and everything, it got postponed. But it's one of the top competitions in the MENA region to be done by Gulf countries and things like that. There was also a local one in Saudi Arabia. I remember it was my first programming competition. It was in King Khalid's University in Abha. It was very nice. It was called the NC3. It usually happens locally rather than being international. It's also a fun competition. If it ever opens, make sure to go for it. Just try and face the beauty of being into a competition. You really feel like you're in a gaming contest or things like that. There's a scoreboard and everything. You really need to experience competitive programming. All right, so the key to anything about programming is to practice. As you can see, I wrote practice so many different times because this is the only way to really improve your programming skills. Memorizing codes or things like that will not really help or might not increase your logic thinking. However, practicing will really increase that for you. That's why I suggest whichever language that you learn, rather than just applying different things, you really have to focus on projects and try to see how that language is being used. This way you practice that language on a real life scale, rather than just tiny dummy programs that you try to see or just try to complete your project with. All right, so we can't mention programming without bringing the mentioning GitHub or Stack Overflow. Now, I'm sure you always hear this. You always see people encouraging you to have a GitHub account or a Stack Overflow account. And I'm here to tell you that as well. You really need to start getting involved into GitHub and Stack Overflow. To explain them individually, GitHub, to set it in a nice way, I would say it is your technical LinkedIn. By what do I mean by that? GitHub contains all the projects that you apply for in terms of programming. Let's say you had a project in one of your courses, which you have done several codes and things like that. Uploading that code is something. It is your own work. Let's say you went to an interview at a technical company. how will they know how much of a good programmer you are? They can't just ask you questions and verbally, and they're going to know how much of a good programmer you are. They need to see something. They need to see something factual in front of them. That's where GitHub comes in place. It shows all the different projects you've done, all the different languages you've used, all the different projects you have tried to implement into different languages. So I highly, highly recommend that you watch tutorials on how you can upload those codes and how you can try to, let's say, implement on other people's codes and let people edit on your own. It's a really nice communication through different coders. And for Stack Overflow, I'm sure most of you know this by university or trying to think, trying to search or Google your programming questions. That's honestly how I got introduced to it. I did not know how important it is until I really needed an answer on one of my assignments. And then I had to search for the answer, and I found most of them over there. Now, how would it help you as a career pathway or things, something like that? Stack Overflow would, let's say, show your expertise levels after you have learned programming. Let's say you see people answering people's questions, they try to implement or try to fix their codes or debug all the errors they have. That's what you can do on Stack Overflow. No matter how much of a beginner you think you are, helping other people increases your networking of answering questions and helping others, as well as being a practice for you. Sometimes you focus on one thing and forget that sometimes there's a whole different thing that you haven't learned or even tried as well. So make sure to also create an account in Stack Overflow to really increase your market share and have a network of your codes and being helpful in that way. All right. If you have any more questions, kindly jot them down in the chat and ask. I'll be here for answering any of your questions. Other than that, we're done. And thank you for attending this session. It was really fun for me. I hope it was as fun for you. Make sure to follow DSC Saudi at Twitter. The link will be sent below. And also make sure to rate this session. I'd like to know what you thought of this session, what you liked, what you did not like, what you feel we can improve for later sessions. Other than that, thank you for coming, and I would not like to take more of your time. Thank you so much. Unless you have any questions, thank you. And make sure to participate in the challenge, all right? Don't forget. All right, I'll keep it on the questions if any of you have any questions. All right. Okay, I got the first question. What does the numbers under the slot represent? What do you mean in the little man computer? The numbers under the slot. Do you mind just explaining further on which slot exactly? All right, so about the challenge, where do I post it? As I mentioned, make sure to see the challenge at @DSCIFOT_ and post your answer. Of course, where do I post it? On your account, but make sure to tag DSC Saudi and myself so I can check your answer as well. All right, the low-level languages depend on binary system. Thank you. Okay. Yeah, okay, to answer your question, yes, the low-level languages, they mostly depend on the binary system, but there are several types. As I mentioned, there's the assembly language. It is a language on its own, and then it depends on the binary system, which is the ones and zeros. There is that kind of translation that happens in between. Now, hash code is happening every year. Yes, hash code happens yearly, and it happens by rounds. You get qualified into different rounds until you get into the different rounds. Make sure to check hash code. Just type hash code on Google. You're immediately gonna get the website. I'm not sure one of the team members can send it, but you can find hash code on the internet and participate in the competition as well. You're gonna learn a lot, trust me. It was one of my favorite competitions, even though I did not make it to the other rounds, but it was a huge learning experience since it's one of the top programming competitions. All right. Okay, so for the practical part, yes, make sure to apply more on the Little Man computer. It helps you think of how your program goes. All right. Okay, give us the link for the attendees. I hope one of my team members can send it right away. Yes, yeah, it's sent right now. Okay, for the other questions, what is the best laptop for AI major? All right. If we're talking about best laptop, this is a very broad question. You can't just ask someone or just get a definite answer on which computer is the best. Okay. That's why specifically for myself throughout the AI journey or something like that, nothing really mattered except having a really high processing for the computer, meaning that the RAM should be high. Not the RAM, what's it called? Yeah, the processing of the computer, the gigahertz of the computer should be higher. For example, the laptop I own right now is around 16. Yeah, some people aim for the 32 or higher, but I feel that's what would be most important for an AI major, especially since you'll be dealing so much with mostly with the machine learning and programming specific hardware and things like that. All right. Could you repeat the question challenge? Okay, so as I mentioned, the question challenge, you can find it at dsci_. Again, it is to try to implement a program where if I input a number, the program is going to output a 1 if the number is even, or output a 0 if the number was odd. Okay, make sure to post your answer and tag at DSC Saudi and myself to check your answer. Someone wrote Mac is the best. Agree to disagree. Everyone has their own uses, everyone has their own points, but definitely do choose what makes you comfortable. All right. Someone says, in the meantime, I'm participating in a competition at my school. I feel the enthusiasm. Make sure to really participate into programming competitions. It's really another level of programming and another level of the joy of programming. It really does help increase your knowledge in so many different factors, whether it be in programming itself or networking with other programmers. It really, really does help to participate. No matter how timid you feel you are, I was very nervous at beginnings, but just go for it. All I'd say is really go for competitions. All right. Someone says, I think I edited my response yesterday. It may be checked by one of the team members. Yes, it can be. They're going to check most of the responses constantly right now on the chat. All right. Someone says, thank you for your effort. Thank you for attending. All right. That's a programming competition. All right. The programming competitions I mentioned are the top 3. Of course, there are several other programming competitions, but definitely aim for them and try to participate in as much of them as possible. All right. Not a question. All right, one of the questions was related to the, what's it called? To the, I forgot, oh my God. Related to the certificates. Yes, make sure to answer the form that is being sent right now in the chat in order to get your certificate and get that now. All right, doesn't this course end at 6? It was going to end at 6, but the but it is kept open for questions and for any questions in the practical part itself. All right. All right. There's a question that talks about the blockchain and how it works because of the assignment. I'm not sure if that's directly related to what I mentioned, but definitely search about it rather than what I'd mentioned. All right. What is the best programming language to implement mobile banking application? All right. When you talk about programming applications, it's considered to be a very wide factor. Programming applications means you have to decide whether it be an Android development or an iOS development. That's the first thing. And if you want to combine both, then you'd go for systems like Flutter, like Google's Flutter system, or Ionic, which can help you do both at the same time. It really does depend on what you need and what you exactly want to implement, but definitely for a banking application, check your audience first. Check what does your audience want. Do they really want it more to be of an application or a web application? Maybe specifically, let's say programming it to be an Android application would not help, since maybe most of the users are iOS users. Maybe they would use this system more on a laptop. So then that way you would create a web app rather than simply just programming an application on its own. All right. But definitely for each, for whichever, let's say, area you would like to choose to develop, make sure to first search on who will be the users and what will the target users want the most. As I said, best language, definitely check which one you want first, and then see what are the best languages for what you want to implement. Okay. All right. All right, someone says, English teacher, thank you for being a great audience. All right. All right, someone is asking if I can put the picture that has the programming competitions as well as the competitions. I will do that right now instead of the questions. Yes, this one. All right, remember, as I said, I put 3 in each because I put the top 3 that would be related, but there are definitely more things than this. All right, you can practice in many more websites, but these are the top ones that I recommend. I specifically use HackerRank, which I enjoy the most, but definitely those 3 are also useful. As well, same thing goes for the competitions. Those are the top 3, but there are definitely so many other competitions. All right. Someone says, can I speak about Python language? You're a prep year at university, and this year you're going to learn about it. First of all, best of luck on your semester, and I hope you really enjoy Python. Python is one of my favorite languages. To speak about it more, it is used in many different places. That's why it's considered to be the top in the world, because it is used in many different areas, whether it's web development or specifically in AI and machine learning, which is specifically why I really got involved into it. You can also use it to build, let's say, web apps or things like that. It's definitely very easy and you will really enjoy Python. It's considered to be one of the, I wouldn't say easiest, but once you try other languages, you're going to see the difference that Python has brought into existence and how easy it's made things for programmers as opposed to the other languages. You'll really enjoy it, and best of luck with your semester. All right, someone says, thanks a million to you for attending. Okay, can we use such a framework such as the one you mentioned to convert your code to a native app for iOS and Android? Yes, like I mentioned, there's the application that you mentioned. There is also Flutter, which is done by Google. Many of the clubs give workshops about Flutter, so stay tuned for that. You're going to find those details at DSC Saudi. You can also use Ionic. Ionic also helps you write one code, and that code can be transformed into a web app, into Android development, as well as iOS development. So there are such frameworks, but you have to really be familiar with that framework and really get to know if all the features are going to happen in all those different applications that you wanted, like iOS or Android. I have used Ionic before, so I do recommend it, and Flutter as well, does work to give the same purpose of being a framework for different types of, let's say, applications, for iOS, Android, as well as a web application. All right. Someone asks what's the best website to practice. Again, the slide I have here is what shows the top websites that I recommend for you to practice, and make sure to practice all the time as well. And specifically HackerRank, which is the one I personally use. All right. All right. Okay, someone says that they forgot to fill in the first form. Make sure to fill out the form that is being sent right now in order to really get your certificate and claim it. All right, someone asks where I'm from. That's very personal, but make sure to check my Twitter and you can tell over there. All right. Someone asks, is assembly language still used, or is it used to explain the computer's brain system? That's a very good question. It is still used, yes. Where it is used specifically to deal with hardware itself, all right? I took, there's that program that tells you about Arduino and all those different microprocessors that you can try to implement hardware. Some of those, to use specifically and to use advanced features in it, you will have to use assembly. Because think about it, it's like you're creating functions or things that are, done from scratch throughout the assembly language, all right? So if you're dealing with more hardware, with more of, let's say, editing functionalities of the computer specifically, you will have to use assembly language, and that's the top reason that why would someone use assembly language. Logically, as I mentioned, no one is going to use assembly right now to create a website or develop an application, but definitely to program hardware, and definitely to create or edit specific functions in the computer itself. With the operating systems, some of them do require you to use assembly in order to edit the computer itself and the uses of the computer itself. All right. Anyways, another question says, what's the language as a beginning? All right. Okay, so in case you're just beginning programming and you don't know where to start, or you're still confused on which language to start, you can, what I suggest personally is first to check where you want to get headed. Personally, that's what I did. I first searched where I wanted to get headed, what I wanted. Did I want to develop applications? Did I want to do that? And then, even if I did not know, you try to do a project in each of those. That's why I recommended GitHub and to practice on different websites, because it is recommended that you try different languages and do apply those different languages in different places and see which one works for you and what you like the most. But as a true beginning, and you have no idea where to start, and you really want to just get involved into programming itself, then I do recommend the top language right now, which is Python. You can use it in many different uses. So as you can see, if you learn this language, you can later decide on where to use it. You can implement it in many different, let's say, areas which you like to get involved with. All right. But I do recommend Python as a beginning, since it's easy and it's the closest to the English language as compared to the other, let's say, the other languages. I did start with JavaScript at school, not JavaScript, Java. I did start with Java in school, which is considered to be too much typing for the, as a beginning. But but it's not used as much right now. That's why I would recommend as a start with Python, but definitely check which area you would like to get involved with first. All right. I guess if those are all the questions, then that's where I'm done for today. Thank you for attending, and thank you so much for bearing till the end, and thank you for all your questions. If you have any further questions, make sure to contact me on Twitter at Ragad Zara, my name, and definitely feel free to ask any more questions, and I'll be glad to help you. Make sure to also register into the challenge and tag all the accounts that I told you to tag, and tell me what you think of this session. And I really, really hope you enjoyed it. Thank you so much. Okay. Thank you, everyone. If that's all for the questions, then we're done for today's session. Okay, someone suggested a YouTube channel, Free Code Camp on YouTube. It would be helpful, definitely. On YouTube, I'd also suggest CS Dojo, which he explains specifically very specific things in programming. Definitely the next level after object-oriented programming is data structures, and then you get involved into other things. So definitely you can start watching either whichever type of learning you enjoy, whether it be through application or through the, let's say, the videos or things that would be more visual to you. Okay. If there are no more questions, we're done for today and you can leave. Just make sure to answer the form first before leaving. All right. Okay, so for those who are asking about the link for the feedback form, it is being sent and keeps being sent, so make sure to fill it out. All right. So as I said, we're done for today's session. Unless you have any other questions, make sure to attend the other session, which is happening today at the Tech Week Bootcamp. Allow me to put it. Today, we'll have a talk about autopsy, and is more related to security. For those of you who are interested, make sure to attend the session. All right. Okay. Yes. All right. Yeah. So for today, there is the other session, which is about encryption of coding from the past to the present. Make sure to attend that. As of now, thank you for attending. All right. Someone is asking if the first workshop they attended has a certificate. All the workshops in the Tech Week Bootcamp have certificates. Just make sure to fill out the forms. Send us the slides, please. Okay, I'll try my best to send it, and I'll try to put it on my Twitter itself. You're gonna find it at Ragad Zara on my Twitter. I'll be putting it there, and I'll try to ask my team if we can send it as well through email. But you're definitely gonna find it on my Twitter, all right? Or at @DSCAffet_. All right, thanks for everyone. Thank you all for attending. Thank you for bearing throughout the